Math 3, Unit 8, Section 5. Today we will be talking about radians. Pretty exciting. Okay, so we're going to go ahead and read this paragraph. For the last few days we've been working with angles using degree measure. However, degrees do not take into account the size of the radius for the circle and therefore do not give us the length of the arc. So remember the arc is like your curved part here? Associated with the angle. Radian measures for angles does, since it is defined as S equals R theta, or theta equals S over R, where S is the length of the arc intercepted by the angle theta, and R is the radius for the circle associated with this angle in standard position. Now this sounds like a bunch of information and way more difficult than it is. Okay, so reading this next paragraph. Since radian measure is new for us, we need to relate it to degree measure so we can understand it. We are dealing with a circle, and we know that the circumference of a circle is what?
2 pi r.
2 pi r.
There you go.
Okay, now, in the unit circle, the radius r is always equal to 1. So the circumference of the unit circle is 2 pi times 1. Because like we said, the circumference of a circle is 2 pi r. And so we're plugging in 1 for r. And you multiply that and you get 2 pi. So now we have a relationship between degrees and radians. 360 degrees equals 2 pi radians. Okay, so there's a couple important pieces of information. Okay, if we know that the whole circle is how much?
360.
360, but in terms of radians, it is 2 pi. So radians are dealing with pi. So a whole circle is 2 pi. How much would be half of a circle? What would be at the 180 mark? 1 pi, or we could just say pi. Okay? Now, if we take 180, which is just pi, and you cut that in half, how would I write that? Half a pi, or I'm going to write it as pi over 2. So basically, we know that each quadrant, each 90 degrees, is pi over 2. Okay? So if you have 1 pi over 2 and you add another 1 pi over 2, you get 2 pi over 2, which we reduce to just be pi. And then if you add another 1 pi over 2, what would this be? So let me help you out so you can visually see this, okay? So if this is, you're close. So do we all agree that pi over 2 plus pi over 2, this is like a 1 pi over 2 and a 1 pi over 2, and you add that together?
Oh, 2 pi over 4.
You're getting closer. So this right here is 2 pi over 2, which we say does reduce to be just pi. Now, if you have 2 pi over 2 and you add another 1 pi over 2, what do you get?
3 pi.
There you go. 3 pi over 2.
3 pi over 7.
Ooh. So we have some work to do there. So then you add another 1 pi over 2 to this, and you would end up with 4 pi over 2, which reduces to just be 2. Okay. We're adding by halves. Okay? All right. So, based on this information, the first thing we need to do on each of these is we are going to sketch our angle. This is our radian angle in standard position. Okay? And then we're going to identify the quadrant. And we are going to, what else? Oh, find the reference angle, all in radians. Okay? Now, based on how we made this unit circle right here, we can make the other ones here, but we're just going to have a different denominator. Okay? So, on our original unit circle, we had a denominator of 2. This time we are dealing with the denominator of, very good, 5. Okay, what would make this reduce to be 2? What would I need on top if my denominator is 5? Very good. This would be 10 pi over 5. What would be over here? We want to keep the denominator of 5. This one always ends up needing to equal 1. So this would be 5 pi over 5. Now, to get up to the 90-degree mark, we cut 5 in half. What is half of 5? Even though this is not normal, we're going to put that as 2.5 pi over 5. And then we know that this is adding a 2.5, correct? And so down here, this would be, yep, 7.5 pi over 5. And we'll get to keep practicing this. So 6 pi, based on that information, will end up in which quadrant? Very good. Quadrant 3 is correct, because 6 is in between 5 and 7.5. So we start at our initial side, we go around, we're going to mark this just like we did with our degrees. This right here is 6 pi over 5. It is in quadrant 3. The reference angle is just like what we did with our degrees. It always goes up to the x-axis. Very good. And so if we draw this up, okay, we're trying to figure out, well, how do I get from 6 pi over 5 to 5 pi over 5? But remember, our reference angle is always positive. And so how much is from here to here? 1. 1 pi over 5. Or, yeah, we'll write it as 1 pi over 5 so that when you look back at your notes, you know that there's a 1 there. Okay, any questions there so far? All right, let's practice another one. Okay, so this time we're going to deal with what denominator? 9. And so we're going to label our unit circle. And if you want to, go through and put a 9, you know, at each of the quadrants. Okay, now this first one we know it always reduces to be 2. So what would need to be in our numerator? Very good, 18 pi. Because 18 divided by 9 reduces to be 2. And a whole circle is 2 pi. What is going to be on the other side at the 180 mark? 9 pi. In order to get the 90 mark, we have to take half of that. What is half of 9? 4.5 pi. And then to get your 270 mark, we just add another 4.5, and that would make what? 13.5 pi. Based on our label now, 5 pi over 9 will end up in which quadrant? 2. Very good. Okay, so we have 5 pi over 9. Okay, we know it's in quadrant 2. Now for our reference angle, we know that we always go to the x-axis, and it's always positive. So what will it take to get from 5 to 9? Very good. The reference angle is 4 pi over 9. Also remember, there's actually 3 things about our reference angles. It always goes to the x-axis, it's always positive, and it's always less than 90 degrees. So in terms of answers, they should always be less than your 90-degree mark. Yes? Yes. So it's sometimes we're subtracting from there, sometimes we're subtracting from the 360 mark, and sometimes we're subtracting from 0. So it just depends on where you're at, but always one of those 3 numbers. Okay, any questions? Does it seem relative? Yes?
I'm just confused on how you got why'd you start with 18?
So our original problem has a denominator of 9. So therefore, I want the whole circle to be in terms of 9, okay? Now I started with the 18 pi over 9 because I know a full circle is 2 pi. And so what with a denominator of 9, what would make it reduce to 2? Okay? All right. So moving to this next one. This time my denominator is going to be 10. Okay, I'm going to give you about 20 seconds to finish filling out just what numbers are supposed to be on the unit circle. So what's going to make this reduce to be 2 pi? 20 pi. What is half of 20? So over here we have 10 pi. What is half of 10?
5.
So up here is 5 pi. And then we have to add a 5 in order to get our... Very good. Okay, now 23 pi. Where am I going to end up? Very good. So we have to make one full circle. Excuse me. And then how many? We go up here. We're in quadrant 1. We have 23 pi. Okay. Reference angle. Always goes down to the x-axis, and we're trying to figure out how many does it take to get from our 20. I forgot to put 23 pi over 10. Very good. 3 pi over 10. Do we have any questions? We're good? Okay. Let's try this next one on your own. Completely on your own. Get your quadrant, get your reference angles. I'm looking for somebody to come up and do the problem. Yeah, extra credit or candy.
Why? Can't you do it up there?
Sure. That's how confident I am that you guys know how to do this.
Wow. Sorry.
There's 2 reference angles. It's pretty
Okay, Tigran's going to go through this. So notice that he started with the denominators of 9, okay, based on the angle they gave us. So now he's going to fill in the rest. 9 times 2 is 18, so 18 pi. The other side is 9 pi. Half of 9 is 4.5 pi, and when you add that on the bottom, we have 13.5 pi. Okay, so where will 16 be? It will end up there, perfect, in quadrant 4. Okay, and so that's 16 pi over 9, and the reference angle what did you put? Yeah, 2 pi over 9. Sorry, I couldn't read it for a second. Perfect, well done. All right, do we have any questions? Okay, the next one's dealing with negative. So it's clockwise. Yeah, so we're going to go clockwise. We still are going to label it kind of the same. You might want to, I'll show you, you have some options. But, so our denominators are all 5. Okay, on this one it's going to be, at our 360 mark it's 10 pi. We know at the 180 mark it's 5 pi or half circle mark. Half of 5 is 2.5 pi, which means down here will be. Now, there's one thing is because we're going negative, if you wanted to write these as negatives, you could, and I don't want to confuse you, but if we were going down, this would be negative, which means if I'm going down 1, this one would actually be the negative 2.5. This would be negative 5, and this would end up being negative 7.5. So if you get confused by negatives at all, you might want to count the other direction and write them as negatives. Okay? So what quadrant will negative 3 pi over 5 end up in? Very good, quadrant 3. Yes?
So even when you're going negative, the quadrants always go 1, 2, 3, 4.
Quadrants will stay the same, yeah. So this will still be quadrant 1, 2, 3, and 4. But in terms of counting, we can count negative if we want to, so it's more clear. All right, so quadrant 3. And then what will my reference angle be? Very good. And reference angles are always positive, always go to the x-axis, and should always be less than 90 degrees. Okay, and so 2 pi over 5 is correct. All right, you guys ready to try this other negative one on your own?
Sure.
Okay, I'm looking for another volunteer. All right, Lawrence.
Yay. Wait, do I have to just put the answer or the whole problem done?
You have to do the whole problem, but I'll talk through it unless you want to.
Time to look at my terrible handwriting. Okay.
All right, good. So this time we're dealing with the denominator of 2. So it's always a good idea to go through and mark up your quadrants. Okay, so wait. 2 times 2 would make it 4 pi.
I'm being stupid.
Good. So we have 4 pi over 2.
Does pi over 2 work?
Yeah,
Just like
no, yeah, pi over 2 is good. Now the only thing that you might want to think about though is because it's negative, we might want to switch the numbers like how I did on the last one. But it's up to you.
It's easier.
You're okay like that? Okay.
Yeah.
So 5 pi over 2, we're going clockwise because of it being negative, and it does end up in quadrant 4. And the reference angle is...
Oh, wait.
So this is actually it doesn't end up in quadrant 4, and I kind of, does anybody know where it ends up? I actually realize now that I kind of gave you a hard one, because there isn't a halfway mark in here. This is 1 pi, right? So if you're going, do you know where to go?
Yeah,
Where does it end up?
I know
with?
exactly. It doesn't lie on any quadrant.
Exactly. It's called a quadrantal. Yeah, quadrantal is where it ends up between 2 quadrants. And so all you would do for a quadrantal is write the 2 quadrants it's in between. So what 2 quadrants is it in between?
3 and 4.
3 and 4, and no solution. Well done. Good job. Okay, so I'll count through this for you. It's hard to see. Okay, I'll write over in pen. So we have 4 pi over 2. I'm going to go ahead and do the negative this time. So this would be negative pi over 2. This is negative 2 pi over 2. And this is negative 1 pi or negative pi over 2. When you're going negative 5 pi, we know that we're going to go a full circle around. And then you have to go 1 more pi. Isn't the problem 3?
Isn't the top one 3? Because you have to add 1.
Yes, thank you, Candy. Okay, and you end up here, because that's 1 pi, okay? And so this is, like I said, that is called a quadrantal. I think that's how you spell it. And it's in between 2 quadrants, which is quadrant 3 and 4. And because it's on a line like that, the reference angle is actually no solution. There is none. You could just put none, or you could put no solution, either way. Okay, do we have any questions? All right. Are we ready to move on? Okay, I'll wait. Do we have any questions before we move on? Okay. Okay, I'm turning the page now. So,
We don't have to do that?
We are going to skip this part. It's not going to be on the test. We're going to go ahead and, but you should know at least these definitions from a long time ago. Complement. When are angles complementary?
90 degrees.
Very good. Add to be 90 degrees. Supplementary, add to be.
180.
And just for fun, in terms of radians, 180 is how much?
90. Wait. Just kidding.
That is just pi, right? Because a whole circle is 2 pi. And 90 would actually be half of that, which is pi over 2. Okay. All right. Side conversations need to stop, please. All right. Now, you need to know this. What does coterminal mean? We've talked about coterminal.
No.
Okay, terminal. Terminal means it's going to end, right? Okay. Now, coterminal means they're ending at the same point. Okay? So coterminal angle means we want to find where they're going to end at that same exact point. When we did this with degrees, what did we do? How much is a full circle? 360. So when we were dealing with degrees, in order to find a positive coterminal angle, we just added 360. When we wanted to find a negative coterminal angle, we did what? We subtracted 360 until we got a negative number. Okay? So we're going to do the same thing now, but with radians. Okay? Now, if I'm adding 360, okay, with a denominator of 4, so like if, and I'm just going to draw a little picture, okay, what would this end up with at the 360 mark? I heard someone say it. I was just waiting for more people to say it. What would be this marking right here if my denominator is 4? 8 pi. Do we all agree with that? So, guess what? To find a positive coterminal angle, we are going to take the angle that we are at and we are going to add 360. We're going to add 8 pi over 4 because that will give me a whole nother loop around and I'll end up at the same spot. Okay? Visually. Okay? If I'm going to draw this for you guys here real quick, this would be 4 pi over 4. This would be 6 pi over 4. This is 5 pi over 4. Okay, so to draw you a picture, oh no, why did I put 5 pi over 4 there? I meant 2 pi. Okay, 5 pi over 4 is right here, correct? So if I want to find a coterminal angle, I am just making a whole nother loop around, which means I have to add an 8 pi over 4. So when you add that, what do you get? 13 pi over 4 is my positive coterminal angle. What would I do to get the negative coterminal angle?
Subtract 8 pi over 4.
Exactly. 5 pi over 4 minus 8 pi over 4. And what do you get? Yeah. That's it. Negative 3 pi over 4. Okay, let's try another one. This time the denominator is 6. So we're always going to be adding or subtracting something that reduces to be 2 pi. Okay? With the denominator 6, what would be 2 pi? What needs to be on top? 12 pi. Okay? Do you guys agree this reduces to be 2 pi? Okay, so if we're adding all the way, we're trying to loop all the way around, we have to add a 12 pi over 6. So what would be a positive coterminal angle? 13 pi over 6, because this is a 1 pi. 1 pi plus 12 pi is 13 pi over 6. What would be my negative? Negative 11 pi over 6. How did I get that? I went 1 pi over 6 minus 12 pi over 6 to get negative 11 pi over 6. Okay, what will I be adding or subtracting with the denominator of 3? 6 pi over 3. Are we okay with that? Okay, very good. 11 pi over 3. When you subtract, we get negative 1 pi over 3. So again, on this one, just in case you aren't seeing what we're doing, we're taking that angle, 5 pi over 3, and we're adding 6 pi over 3. On this one, I'm taking 5 pi over 3, and I'm subtracting 6 pi over 3. Do we have questions? Okay, what will I add and subtract for this one? 4 pi over 2. Okay, so what's the positive?
Please report to the attendance office.
7 pi over 2. What's the negative? Negative 1 pi over 2. Or negative pi over 2. Either would work. Okay, do we have any questions? All right. Okay, this one says review. Find the ordered pair on the unit circle for each angle. Okay, so this 300 degrees would start here, loop around, and they just drawn quadrant 4 for you here. This is at 300 degrees. Could you just go and use your unit circle and find out what the ordered pair is at 300 degrees? Yes. Okay, and so if you get your unit circle out, 300 degrees is, that's it. Once you make the unit circle and know how to make the unit circle, you can use it at any time by making it, right? Right now we have it made, so we're good. Can I what? Yes, you'll be making it though, and then you'll get to use it on the test.
Oh, wait, we'll make it before we take the test, and then we can use it on the test?
Yeah, so let's say before I hand out the test, I'll hand out a unit circle and you'll make it, and then I'll hand you the test.
To make sure it's correct?
Yeah. Okay?
Just making sure I'll be using like an actual one that's correct.
All right, so here we go. We have our triangle here, correct? Okay, if this is 1, but we want it to have a denominator of 13, what would I change 1 to be? 13 over 13. We all agree that reduces to be 1? Okay, so again, we're trying to find the ordered pair right here. Okay, but I need to know this length. Right now, do I know, which length do I know, the x or the y? The y, which we know is 12 over 13. We know that x is going to be something over 13, but I don't know what the top number is. Although some of you might, because we, for some reason, keep using this one.
So it's 5?
Yeah. Okay, but if you didn't know that, we would do a squared plus 12 squared equals 13 squared, because we're not dealing with the denominators. And you'd get a squared plus 144 equals 169. A squared equals 25, which means A equals 5. And so our ordered pair is 5 over 13 and 12 over 13. Okay, any questions? All right, last one. Okay, they are asking us to find sine of A, cosine A, and tangent A. Okay? Sine of A, cosine of A, and tangent of A. Now, right now, I know this length right here, but I don't know this length. So I really don't know my adjacent side. And we know here, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. So, We need to figure out some missing pieces. Anybody have any ideas?
3 over 7 and x over 8.
Yeah, we could do that. Actually,
Cross multiply to get d8.
okay, so 3 over 7, setting up proportions. Since these are both 90 degrees, I just don't, let's see what happens. 3 over 7, so we're putting 3 over 7, which means what we're missing right here, we're going to call x over 8. I don't think that's going to work because we don't know the like they haven't given us enough information. But what I can do is we can give this x, okay? And so we could write this as this side being 7 and this side being 8 plus x. Does that make sense? So we're comparing this triangle right here and this triangle right here, okay? So I'm setting those up as proportions, the big triangle and the small triangle. Yes? Are we good? Okay, and so now we can solve. Okay, so we cross multiply. We have 3 times 8 plus x equals 7x. We distribute, we get 24 plus 3x equals 7x. We subtract 3x to both sides. 24 equals 4x, which means x equals what? So this side is 6. Okay, so in terms of our triangle now, we know that this whole side, this bottom part is what? 14. So I'm going to put a 14 here and circle it. That doesn't look right now. This is a 7. And then how could I figure out the hypotenuse? Pythagorean theorem. So we have 7 squared plus 14 squared equals our c squared. 7 squared is 49. 14 squared is 196 equals our c squared. 49 plus 196 is 245 equals c squared. And when we take the square root of both sides, it doesn't work out perfect, okay? But this actually breaks down to be 49 times 5, which would make it what? 7 root 5. So this right here side is 7 root 5. Okay, so now, based on that information, if we're doing sine of A, what is opposite A? 7 over 7 root 5. These 7s cancel out. So I actually have 1 over root 5. And is that answer good? Nope. What do we do? Rationalize it. Good math talk. And we end up with root 5 over 5. For cosine of A, what is adjacent? 14 over the hypotenuse is 7 root 5. We reduce. This 7 cancels out. The 14 becomes a 2. And then we need to rationalize it. We multiply by root 5. And we end up with, very good, 2 root 5 over 5. And then last one, tangent opposite is going to be what? 7 over adjacent, which is 14. And that reduces to be 1/2.